we are talking about subspace and dimension, there can be some misunderstanding because I didn't understand everything right now. But I will go ahead for let V be p-dimensional vector space. There's subspace. Then it can be, if you want to be n-dimensional subspace, then you need n number of independent columns. And for M should be corresponding ambient space it will be inside. For the first problem, it has 3 columns and 2 rows. If we ask if it can space to R3, then it should have 3 independent columns. So it can't span 3 R3. Asking R3 is questionable. R3 questionable. Is it asking column or is it asking row? Okay. More generalized version would be, is it a basis for subspaces? And next question is, we have 3 columns and 3 rows here. In this case, is a basis for R2. We should check that we have two columns, which is independent, and basis for R3. We don't have independent number of columns, so we can't span to R3, but we can span to R2. It cannot possibly be basis for R2 because they do span, so they can be basis of R3. But they are not in R2. In this case, rows has problems, so we can be inside. So you should carefully distinguish it. It is very, at first it will be very complicated. Column question and row questions mixed together cannot be. It is also subspace of R3 columns. We don't have, we have 2 independent. It can be subspace of R3. Oh, so complicated. And another complicated problem was it has 2 pivots. In this case, then it will be it can be basis of subspace, which it makes. Then if we ask what is the dimension of subspace, then it is subspace in R3 or R. In or O R3, but it spans to two-dimensional dimension space. But this is also confusing, very confusing. In or subspace or in or O R3. And number 3 is also very confusing. Is this can be subspace of SS0? If we see that this will be basis of C1, C2, 0, so it can't be it is not inside of H, so it is not a basis. And for eigenvalue, very big. When we solve eigenvalue eigenvector problem, we should use that A minus lambda I matrix is not invertible, for which will be determined is 0. And if we give an eigenvalue first, we can make A minus lambda I matrix. So we can solve this problem. Then there will be some augmented matrix come out. Then we can find an eigenvector or eigenspace directly. Next time, I will more focus on the difference of is this subspace? What is the dimension or what's inside? And can this span to R3 or span to R2? See you next time.